Alright, today we're talking about multiplying and dividing radicals. Your objective that you need to write down is I will learn to multiply and divide radical expressions. Alright, now you maybe remember from Algebra 1 where you had to do what's called the FOIL method, which just means that you take this first term and you multiply it with the second term. So that gives you square root of 3 times the square root of 5, which is going to be the square root of 15. Then you take the square root of 3 and you multiply it with the second term of the second expression, and so you have a negative square root of 3 times square root of 2, so that's going to give you square root of 6, or a negative square root of 6. Then you take this second term, the square root of 6, and you multiply with the square root of 5. So that's, both of these are positive. That's going to give you a plus square root of 30. And then you repeat that, you take the square root of 6 and you multiply again times the negative square root of 2, which is going to give you a negative, since this is positive times negative would be negative. And then 6 times 2 is going to give you the square root of 12. Okay. And then you want to see if you can simplify any of these. 15 would just factor into 3 and 5, so that's going to be in simplest form. 2 and 3 would be the factors of 6. That doesn't produce anything. 30, the same thing, that's simplest form. When we get to 12, that's going to actually factor into 4 times 3. So that's going to give you square root of 15 minus the square root of 6 plus the square root of 30 minus 2 square roots of 3. Okay, none of these have the same radical, so I cannot combine any of these. And they're all in simplest form, so this would be the answer for number 1. Alright, we're going to do the same process with number 2. I'm going to take this square root of 10 and I have to distribute it to both of these terms here. Square root of 10 times the square root of 10, that's just going to be 10. And then square root of 10 times square root of 6, it's going to be positive square root of 60. Okay, now I'm going to take this negative square root here times the square root of 10. That's going to give me a negative square root of 60. And then multiply here. A negative square root of 6 times a positive square root of 6 is going to give me a negative 6. All right, looking at these terms, seeing if there's anything I can combine, I notice that there's a plus 60 and a minus 60. So those are going to zero out. And then I'm going to be left with 10 minus 6, which is equal to just 4. Okay? All right. I'm going to set up number 3 for you. You're going to work on that on your own. But this exponent 2 just means I have the square root of 8 minus the square root of 5 in parentheses. And then I have another one of the exact same thing. Okay. And then you're going to need to distribute there, there, and there. Okay. So I'm going to leave that one up to you. This is one that I will be looking for in your notes to check. All right, now we're kind of review or look at dividing radicals, which is kind of review. We've kind of done this before. I'm going to look at this 12, and the first thing I want to do is see if I can reduce anything. Since the 3 doesn't have a radical on it, but the 12 does, I can't cancel anything out or factor anything out of the numerator and denominator. But I can take the square root of 12, and if I factor that out, that's going to give me 4 and 3. So that's going to factor. So I have a pair of 2's that come out. The 3 is going to stay inside. So looking at this, it's going to be 3 over 2 square roots of 3. Okay, but remember, I can't have a square root in the denominators, so I need to take the square root of 3 over the square root of 3, because I want to force the denominators to be a perfect square. So that's going to give me 2 times 3 on the bottom. On top, I'm going to have 3 square roots of 3. Okay. I can factor out a 3 from both the numerator and denominator. That just becomes 1 and 1. So I'm left with the square root of 3 over 2. Okay, I no longer have a radical in the denominator, so I'm done with that one. Okay. On example 6, what I always want to do here, since both of these are inside the radical, I can actually factor that. And if you want to do that, you can actually do it on the calculator. You'll hit alpha y equals, enter, 5 in the numerator, 175 in the denominator. Okay, so I got, now that I have square root of 1 over 35, okay, I can break that into the square root of 1 over the square root of 35. The square root of 1 is 1. And like before, I can't have a radical in the denominator, so I'm going to multiply square root of 35 over square root of 35. These two pair up and just become 35 without the radical. 1 times the square root of 35 is the square root of 35. Okay, now if I were to kind of come over here and look at factoring 35, that's going to give me 7 times 5. 7 and 5 are both primes. That doesn't simplify the radical. So this would be my answer. Okay. All right. This example down here, same thing. Since I have square roots, I can actually combine those. 441a squared over 7b. And I want to check if I can reduce this if at all possible. So again, I'm going to go alpha y equals, enter. I'm going to do 441 over 7. And that does equal, that comes out to 63. So that's that inside the square root. And I'm going to kind of do some side work. I'm going to look at the 63 and see if I can factor that out. So that comes out 9 times 7. 9 is a perfect square, so that 3 comes on the outside. 7 is going to stay on the inside. So I'm going to have 3 square root of 7. Now I'm going to look at the a. Since that's a squared, I can go ahead and take the square root of that and just get a. Then I have the square root of b as my denominator. And I multiply top and bottom by the square root of b. Right, so that's going to simplify to 3a square root of 7b and then just over b. Alright, this last example I want you to try on your own. And this will be an example I will expect to see in your notes.